Good morning, ladies and gentlemen. Today we're on page 249, and we're actually going to be doing two lessons today. We're going to be doing lesson 6 and lesson 7 in this video. Okay, so our objective today is we're still continuing with patterns, but we're going to be looking at them in a different format. So our goal today is, today I will find addition and subtraction patterns in input output tables, period. Okay, so today I will find addition and subtraction patterns in input output tables. Okay, so let's talk about these input-output tables. Okay, so here's our vocabulary, and we already have discussed what a pattern is and a rule is, but let's talk mainly about this bottom part, because this is our new part today. So input says the number the rule is applied to, and output is the outcome after the rule is applied. So think of putting something in this magic box, and then the rule is it does something to this number, and then it spits out a new number. So let's look at an example of one. They told us what the rule is here. The rule is they added 5. So if you put a 4 in and you add 5, it's going to spit out a 9. If you put a 12 in and it's going to add 5, it's going to spit out or put out a 17. If you put in a 25 and they add 5, it's going to put out a 30. So that's what it's called, an input-output table. Now we also have one where the rule is subtraction. So if I put in a 9 and they subtract 5, it's going to put out a 4. So that's what happens in these input-output tables, is you kind of think about, you throw in a number in this magic box, they do something to it, and then they put out another number. Okay, and remember, this one says we're looking for addition and subtraction patterns only. Okay, so I'm going to do my first one with you. Here's my first problem. And it says, the first number is, it puts in a 36 and it puts out a 24. So my number got smaller, which means I know it has to be subtraction. Right? If my number is getting smaller, I know it has to be subtraction. But what was subtracted between 36 and 24? What did they subtract? Well, I can figure that out by doing subtraction. So 6 minus 4 is 2. 3 minus 2 is 1. So they subtracted 12. So 36 minus 12 equals 24. Does that rule continue? I probably want to check it at least on one other. So I can choose either. Maybe I'll choose this one. If they put in a 55 and my rule really is take away 12, would it be 43? Let's see. 5 take away 2 is 3. 5 take away 1 is 4. So that is really my rule. My rule is take away 12. But I'm going to try at least 2 on each one. Okay, let's look at my next one. Okay, my next one looks like this. Okay, and this time they actually tell me the rule. They actually told me the rule. So I don't need to find the rule. They told me the rule is plus 7. So they said if you put in a 4, they added 7, you get an 11. They want me to solve for these x's. Those are called variables. So what are my x's? Well, if they put in a 12 and they added 7, what is 12 plus 7? 2 plus 7 is 9, and 1 plus nothing is 1. So this x equals 19. So what does this one equal? 23 plus 7 equals 3 plus 7 is 10. 1 plus 2 is 3. So this x, or variable, equals 30. Okay, let's try some of those together. So we are on page 250. And here is our first one. It looks like this, and it says they want us to solve the rule here. So let's think about this. They put in a 6 and it spit out a 12. So my number got larger. So I'm only looking for addition or subtraction, which means this must be an addition rule. They must have added something. So what did they add to get to 12? Let's see, 6 plus what equals 12? So I could do an inverse operation and subtract, but I also think I could just count this one out on my fingers and say 6 plus 7, 8, 9, 10, 11, 12. So I know 6 plus 6 is 12. So I think that's my rule, but I might want to check it on another one. So is 12 plus 6 really going to give me 18? Let's see, 2 plus 6 is 8. 1 plus, it does. So my rule, because I want to check it twice, is add 6. Okay, let's try the next one. This one, they told us the rule is minus 8. So they said that 32 minus 8, or take away 8, equals 24. And they want us to solve for these two variables. So we know the rule is going to be take away 8. So what is 40 take away 8? Well, 0 take away 8 I can't do, so let's borrow. 10 take away 8 is 2, and 3 take away nothing is 3. So our first x equals 32. And then they have 16 take away 8, because our rules take away 8. 6 take away 8 is not possible, so let's borrow. 16 take away 8 is 8. So this variable x equals 8. Okay, so ladies and gentlemen, I want you to pause the video and you're going to do the next pages on your own. And then when you're done with that, I want you to start the video again, because we're also going to be doing lesson 7 together right now. So we're also going to do lesson 7 together. So pause the video, do those problems, and then restart it, and we'll do lesson 7. Okay, ladies and gentlemen, lesson 7 is going to be very similar. The difference is, as now we're going to say, today I will find multiplication and division patterns using input, output tables. So now, instead of doing addition, subtraction, we're going to look for multiplication division patterns using these same tables. So the idea is going to be exactly the same, except our patterns will be different. Okay, so they do give us some examples of some multiplication division input-output tables, but I'm just going to get started and show you them. Okay, so here is my first one. And if we don't know our basic facts, we might need to use an array for this. Hopefully we know our basic facts because we've been using a lot of reflex. Okay, so if I see 45 and it turned into a 9, so they put in a 45 and it put out a 9, I know it got smaller. So between multiplication and division, I know division is how numbers get smaller. So 45 divided into what equals 9? I know that 45 divided by 5 equals 9. And I know that as a basic fact. You might have to do an array if you don't know this, okay, to help you. So I'm going to check at least another one. Is 25, if I divided 25 into 5, would I also get 5? Yes. So my rule is divide by 5. Okay, let's look at our number 2. This tells me the rules times 7. So I know my rules times 7. 3 times 7 is 21. So they want us to solve for these x's. So 5 times 7 equals 35. And 6 times 7, that's a little bit of a trickier one. 6 times 7 is 42. So my variables equal 35 and 42. Okay, let's try two of these together. We are on page 258, and here is our first one, and it says 6 was put in, and 12 was put out. So 6 to 12, so it got larger. So between multiplication and division, I know multiplication would make it bigger. So I know it's a times. So 6 times what equals 12? I know 6 times 2 is 12. And then let's check another one. I also know 12 times 2 is 24. So our rule is times 2. Okay. This one says, they tell us our rule is divided by 8. So 24 divided by 8 is 3. And they want us to solve for our 2 x's. So what is 40 divided by 8? And you can also use the inverse operation to think 8 times what equals 40. So I know 8 times 5 equals 40, and that fact family helps me. Because 40 divided by 8 equals 5 means 5 times 8 equals 40. That's called the fact family. So knowing that helps me. So 16 divided by 8, I can also think of 16 divided by 8 equals what? Well, 8 times what equals 16? And I know 8 times 2 equals 16, so my answer is 2. Those fact families really helped me a lot. Okay, so ladies and gentlemen, you have the rest of these problems to try on your own. Have a great day.